Number 8, we have the integral of e to the power of 5x. Which function can we differentiate to get e to the power of 5x? Well, it's going to be another exponential function, right? Using the rules for differentiating exponentials. Let's try e to the power of 5x. If you differentiate that, you get 5e to the power of 5x. Great, that's close to what we have here. How can we get rid of this 5 factor? Well, we can try differentiating 1 over 5e to the power of 5x. And then when you differentiate that, you get 1 over 5 times 5 times e to the power of 5x. These cancel out, and we're left with our integrand. So the correct answer is indeed 1 over 5 e to the power of 5x plus c. So at the beginning, there is a little bit of guessing to do, but with practice, you won't need to guess and you'll know the answers right away. So let's move on to the next one. Oh, and I've messed up the numbers here. It should be 9 and then 10 and so on, but ignore that. We have the integral of tangent squared of x. Okay, so that's a little bit more tricky, but right, since we don't know any functions which differentiate f dashed of x to be tangent squared of x, but we can use trigonometric identities to transform this. So I'm going to derive the trigonometric identity myself since I don't want to use the formula booklet. But if you have a formula booklet with this trigonometric identity, you can, of course, use that without deriving it yourself. So to derive them, we start with sine squared of x plus cosine squared of x equals to 1. This is just Pythagoras' theorem in a unit circle. So we can divide both sides by cosine squared of x. And we get sine squared over cosine squared is tangent squared x plus this is just 1 equals this is just secant squared of x. And there we go. This is the trigonometric identity. So if we want to rewrite it solve for tangent squared of x, we just subtract 1. So tangent squared of x is secant squared of x minus 1. Now let's replace this integral by secant squared of x. And let's also split the integral. So minus 1. I'll add some more space and add the dx's. Okay. Let's work on the two integrals one by one. Which function can we differentiate to get secant squared? And the answer to that is just tangent of x. Now I'm not adding the plus c yet, but I'll add it at the end since we also have to evaluate this indefinite integral. Now 1 is just x to the power of 0. So let's apply the reverse power rule. When we integrate, we're going to get x to the power of 0 plus 1, which is just x, divided by 0 plus 1, which is just 1. So the integral of 1 dx is just x. And then write plus c. So that's the final answer. the integral of tangent squared dx is tangent of x minus x plus c. So whenever you're integrating, it's always a good idea to keep in mind all of the things you learned before calculus. So that's trigonometric identities, rules of logarithms, exponents, and so on. Next, we have a definite integral from 0 to 0 of the square root of the tangent of x dx. And all you need to know for this one is just remember that rule saying that the integral from a to a of any function is just 0. Okay, and we explained why at the beginning of the video. So I'm just going to say this is equal to 0. 9. Given that the integral from 0 to 1 of x to the power of x dx is a, and the integral from 0 to 2 of x to the power of x dx is b, find in terms of a and b the value of the integral from 1 to 2 of x to the power of x dx. Okay, so this is just working with boundaries pretty much, right? Because all of these inside functions are basically the same. We just have a factor of 1/2 in this one, which we can even pull outside of the integral since it's a constant. And we just have different boundaries, right? Now, we can say that we can pull the 1/2 out, as I was saying, and we can, using this equation, multiply both sides by 2. And when we do that, we get that 2b equals to the integral from 0 to 2 of x to the power of x dx. And I'll just copy this, a equals to the integral from 0 to 1 of x to the power of x dx. Now, what we're looking for, the integral from 1 to 2 of x to the power of x dx is the same as the integral from 0 to 2 of x to the power of x dx minus the integral from 0 to 1 of x to the power of x dx. And this first part right here, the integral from 0 to 2 of x to the power of x dx, is just 2b, as we found earlier. So we'll replace that. And then the integral from 0 to 1 of x to the power of x dx is just a. So we can copy that. And now I'll just make some space. And there we go. That's the final answer. So the integral of x to the power of x from 1 to 2, which is what they're asking for, is equal to the integral from 0 to 2 of x to the power of x dx minus the integral from 0 to 1 of x to the power of x dx. And that is, of course, just 2b minus a. I'll write this a little bit nicer. Okay. Number 10. If the area under y equals sine of x, so that means between this function and the x-axis, from x equals 0 to x equals 1 is a, find in terms of a the integral from 1 to 0 of sine of x dx. Let's transform this first part of the sentence into a mathematical equation. We have the area under the curve y equals sine of x from 0 to 1. So we can use an integral. Here, of course, we just have sine of x, that's our function, dx, and that's equal to a, okay? Then, what is the integral from 1 to 0 of sine of x dx. Okay, so you'll notice that these two expressions are really similar. We just have the boundaries switched. So how can we reverse the boundaries here to get the same boundaries as we have over here? Well, we can multiply both sides by -1. So I'm going to have a minus here and a minus on this side of the equation. And now that we have this minus in front of the integral, we can make it disappear if we switch the boundaries. And that's exactly the integral that we're looking for, okay? And we see that it's equal to -a. So I'm going to erase all this, and we'll say that this is our final answer, which is correct. So we have 4 more examples. The integral of 5x all cubed dx. And here we can just distribute this cube and pull this factor outside of the integral. So this will be 5 cubed, pull it outside of the integral, and then inside we just have the remaining x cubed dx. And then we just evaluate 5 cubed, which is 125, and then apply the reverse power rule. So we add 1 to the exponent, and we divide by the new power, n plus 1. And you have to check for simplifications. This only has factors of 5. 5 times 5 times 5, which is prime. So prime factors are just 5, 5, and 5. And here we just have 4, so it can't be simplified. So this is simplest form, and always add the integration constant, plus c. Okay. Next, we have the integral of dx over the square root of 2x. Now remember, when we have a square root of a multiplication, a times b, this is just square root of a times the square root of b. And same applies for when they're in the denominator. Square root of ab, we can rewrite as 1 over the square root of a times 1 over the square root of b. And that's what we'll be doing here to pull this 2 factor outside of the integral. So I'll say, and the dx comes down, by the way, we'll just have a 1 on top. So this is 1 over the square root of 2 times the integral of, or we can still write the dx on top, square root of x on the bottom. Okay, I'll delete this now. Now we can bring the dx on the bottom, and let's write 1 over the square root of x as x to the power of n, so that we can use the reverse power rule. So it's going, n, the power will be negative, since we have x in the denominator, and it's going to be negative 1/2, since we have this square root, which is the same as a power of 1/2, or negative 1/2 when it's reciprocated. So we say this is just, and we can write this as square root of 2 over 2. And then integral of x to the power of minus 1/2 dx. Okay. And now this will just be, well, let's copy square root of 2 over 2. And then add 1, so times x to the power of 1/2, add 1, and then divide by 1/2. So this 1/2 can just go on top as a 2, and then these two cancel out. So this is just the square root of 2x plus c. That's the final answer. Yeah, we don't have a lot of space, so I'm going to delete some things there. Can delete this. Okay, there we go. So square root of 2x plus c. Next, the integral of 2 minus the cube root of x over the cube root of x. Now we don't have a rule for the integral of a quotient like we do for derivatives. But notice that we have the same term here. So we can just split the fraction, right? A plus b over c is the same as a over c plus b over c. That's the rule that we'll be using now. So we can rewrite, and we can split the integral. So let's rewrite this as 2 over the cube root of x. And we can even pull this factor of 2 outside of the integral. And we're left with 1 on the numerator, minus the integral of the cube root of x over the cube root of x. Okay, I haven't written the dx's, but I'll be erasing this step anyway due to space constraints. So let's rewrite this as 2 times the integral of x to the power of minus 1/3. Sure, we can write dx minus the integral of 1. Okay, these cancel out. Dx. So this is just 2 times x to the power of 2/3 divided by 2/3 minus x plus c. The x coming from here. So these 2's cancel out. This 3 comes on top. So this is 3 times the cube root of x squared minus x plus c. Okay, that's the final answer. So I'll just write that. Okay, last integral of this video, we have a definite integral from ln of 2 to ln of 3 of e to the power of e to the power of x dx. Okay, let's start by just using exponent laws to rewrite this as the integral of e to the power of e times x, okay, dx. Okay, and we already had a integrand of this form, except instead of an e over here, we had 5, and then we had to multiply by 1 over 5, remember? So now let's multiply by 1 over e, and then we still have e to the power of ex as the antiderivative, and we have to evaluate this between ln of 2 and ln of 3. So, let's just make sure that this is true. If we were to differentiate this, this factor of e would come down, cancel out with this 1 over e, and then we're just left with e to the power of ex. So, yes, this works out. And now we just plug in the boundaries. this is 1 over e times e to the power of e times the ln of 3 minus 1 over e times e to the power of e times ln of 2. And this should just be simplest form, I think. Yes, that's simplest form. Nothing can be done. So there we go. That's the final answer. No plus c since it's a definite integral. Always remember that. So I hope you enjoyed this video and it was helpful. And in the next one, we will be covering further rules for integration, just probably maybe exponentials, logarithms. I mean, we've more or less covered it. Really, it's just about guessing sort of the derivative function. But the function which differentiates to the one you want. But the majority of the videos on integration will be focused on actual integration techniques, such as by substitution or integration by parts. These are the two main ones. So U sub and trig sub that we'll be covering. So yeah, I hope you enjoyed the video, and I look forward to making the next one.